morning. Sorry I'm late. Sorry. Hee Today I woke up without my alarm clock. Again, for the third day in a row. But this time I woke up later than I was supposed to. 5:33 instead of 5:20. I'm like, whoa, I'm so used to my routine now. I don't know how I'll save 13 minutes. And then I kind of accepted I was going to be a little bit late. So please forgive me, Lord, for I have sinned. Not as much as this. What the heck? Move it to bottom. That makes sense. Wait, what? Oh. Order, move to bottom. There's 38 sources here on my screen. Order, move to bottom. There we go. And I need you to bring the notifications. If someone, order, move to top. If someone wishes to follow or donate, then we will see that. We will see that we will see that on the screen. There we go. All right, cool, folks. Let's turn on that light behind us. Now you know about all the different platforms I visit most. All right, there's 2 of them. Why is there 2 Firefoxes? That's kind of suspicious. Are you sure we wish to remove it? Yes. Don't need 2 Firefoxes. All right. Today, folks, we're going to do some quizzes about computing quizzes. So let's look for a few of them that we want to do while everyone settles into the stream. Sign quizzes 101 computer. Okay. Let's see what quizzes are there. A* short path algorithm interactive task. That doesn't sound fun. System architecture quiz. Memory and storage quiz. I like that. Computer network quiz. What is GCSE level? GESE? No. I already forgot. GCSE. GCSE stands for General Certificate of Secondary Education. Oh, so it's pretty easy. Wait, where's my quiz? It's telling you all the answers before you even do the quiz. All right, let's see. We'll find these ones. We'll do these ones, computer networks. And apparently that's it's not very hard because it stands for General Certificate of Secondary Education. So I guess we'll get warmed up on those. Computer Septon, cryptic crossword, big O nation, notation. TCP, ICP stack, network, and layer protocols. I'm down. Network algorithms quiz. Then maybe we can switch to another provider of quizzes. So we have 4 quizzes from this supplier. We're going to try to do 10 in total. GCSE computer quizzes explain these questions are suitable for GCSE computer science. Students studying any awarding body specification to fire quick Aston science questions before and will change the questions each time you return. Huh. Oh, nice. I'm down to do it. Let's do it. Vamos. Quick fire quiz. All right, start. Now, which is not a common search algorithm? Linear search, binary search tree. Wait, I think it's between these two. No? Oh, it was bubble search. The most common search algorithm are linear search and binary search. Sorting common algorithm. Okay. Ah, they're sorting. Indeed. Okay, okay. Whoopsies. All right, which of the following is not an important element of computational thinking? Programming, decomposition, abstraction. Which of them is not an important element of computational thinking? Programming, abstraction, algorithm thinking, abstraction, programming. What is computational thinking actually? Don't bullshit me. This one is from BBC. Computer science revision links. All right. All right, telling us that we should study. Nice. Computational thinking is a powerful problem-solving process that uses four main techniques: decomposition, pattern recognition, abstraction, and algorithm. It helps people break down challenges into simple logical steps that both humans and computers can understand and solve. I didn't hear about this. Decomposition breaking down a big complex problem into smaller, easy to fix parts. Pattern recognition, finding repeating trends or shared trends amongst different problems. Abstraction, removing unneeded details to focus on what matters most. Algorithm, writing a clear step-by-step set of rules or instructions to reach a goal. That's really cool. That sounds like a really cool way to work in general. Pattern recognition, finding repeating shared traits among these different problems. I like images. Decomposition, abstraction, algorithms, pattern recognition. This is pretty poorly explained here. I like images, but this is pretty close to useless. Like, are you four parts of the brain doing four different things like that? I don't think so. Why it matters. Everyday use helps planning objects, cooking meals, fixing daily tasks. We actually kind of do it all the time. Just don't realize it, I think. All right, next. Which of the following is the name of a major operating system? Unreal, Microsoft, Linux, no. Apple, macOS. Microsoft is a company. Unreal, isn't it used for video gaming? Apple, macOS, I think. Nice. Unreal is the name of a game engine. Nice. Which of the following is an advantage of the secondary storage? It can be accessed from anywhere. It can be used to store data for a long period of time. The CPU is able to access the data if it is working on extremely quickly. If the data is stored while the device is running and cleared when the power is switched off. Data is stored while the device is running and cleared when the power is switched off. Well, for me, the advantage of secondary awareness is in case something happens to the first one, you always have a second one available. Second data. So, whoops. So, I'm not sure how you say that. It's a redundancy, how you call it. Redundancy, which is part of availability. The data stored can be accessed from anywhere. It can be used to store data for a long period of time, including when a computer is powered down. Maybe. The CPU is able to access its It is working extremely quick. I don't know about that. I don't know about that. Data is stored while the device is running and cleared when the device is powered off. The data can be accessed everywhere. Hmm. I don't know which one it is, but I'm gonna go computer powered down. Maybe secondary storage is actually the SSD, no? No, secondary storage, including while the computer is powered down. Secondary storage devices are usually types of drive which enable computers to store data even when they're not powered on. That was what I said, no? Oh, I said the opposite. Secondary storage are usually types of device which the computers store even when they're not powered on. Do we take notes on this, folks? I think we should. I believe from my crazy intuition. Ooh, wow. Oh, I was gonna say we're pretty deep into the notebook, but not at all. I've had this notebook for like 3 years. It's not even close to full. Hmm. I went to work yesterday and I didn't steal a good pen. All right, so that's interesting. I have notes on what's called computers, and we have a few notes here, folks. We have things about basic computers, such as physical address, virtual address, rings of security. There's a ring 0, ring 3. Ring 3 is the pretty common one, and ring 0 is the very core of the kernel. Also, we know that LMs are deterministic. But they are actually deterministic. Just throwing out some knowledge at you. LLMs are deterministic, but what isn't is the text generation model that they use that outputs the LLM. So that's something that we learned that was pretty cool. If you have questions on that, let me know. Pointers are where there's a value in address memory. There's different types of GPUs. There's different type of MMUs, memory management unit. And distance between components matters a lot. How data centers, cloud environments deal with this? Oh, that's a good question. Distance, but okay. So we're going to do some quizzes today, and then we're going to answer that question. How do data centers, cloud computing environments deal with the distance that is important between memory and CPU, and GPU and stuff like that? Because yesterday we did the math. Mm, Being something like 10 centimeters away loses you a lot of time, even though information travels at the speed of almost information travels at half of the speed of light, more or less, which is crazy. Light travels so fast, like, choo, like that. It's already here. Choo, it's here. So, mm, so it's really fast, and yet we're having problem with that, with the speed of information. It's insane. So my question is, how do you manage this in the data center in a cloud environment? Especially where, if you're a bank and you decide, all right, I need a data center to store my data. I know it's going to be the use case and everything. Have a pretty good idea of the applications we're going to build, so that's good. But then if you're someone like AWS and you have to do it for thousands, hundreds of thousands of clients, how do you make sure that you always have the resources ready for their specific need, the different kind of instances they could use? It's insane. It's insane. Yo, 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 Ross AK. Dancing dinosaur. Hey. Nice. Hey, Ross. Hope everything is good. We're doing some quizzes and talk about the things we did in the past 2 days. But I'm just realizing, mm, you know, some really cool knowledge that we got. Especially, I'm looking at the distance between components matters a lot. Something I never thought about. I thought it was like on one place in the data center you have the CPU, on one other place you have the GPUs, another place you have some kind of like memory, kind of you have RAM somewhere else. But no, all of this has to be really close, and you have to think about everything that you do in the data center and make it scalable. So I was just thinking about that, how crazy it is, and the load balancing and everything must be so crazy at a data center. It's complexity that you don't realize. And on the side, we're doing quizzes. So we're gonna take notes on this one. Secondary storage is a secondary storage. I need to fix my polygrapho. Secondary storage is storage which survives without electricity. Boom. The more I learn, the less I know. Yeah, I agree. Yeah. Insane, no? This kind of thing. All right, I want to brush my hair a little bit more. Or else. Did you get this on the past 2 streams? Did you learn something and you're like, fuck, I know nothing? Every day, baby. Nice. Well, if every day you learn something, it's pretty damn cool. Yeah, honestly, there's very few days where I learn nothing. Can't tell. Rose, any fun plans for the weekend? Car shopping. Oh, nice. What car are you gonna get? Or what car are you thinking of getting? All right, secondary storage is this. All right, if you have 2 gigabytes memory, approximately how many photos can it hold if it can take 20 megabytes? How many photos can it hold if it takes 20 megabytes? I want to pick up a better Japanese car I can clap out and turn into a drifter. What is it? Clap out? I'm not very familiar with cars. What does it mean clap out? Is it pumping it? Is it making it different? If it's 2 gigabytes, approximately how many photos can it hold? A phone photo take 20 megabytes. That's 100, no? 20 megabytes would be, they're quite large photos, huh? 20 megabytes. Yeah, I think so. It's 100. Nice. Out means like modify. Nice. 1024 megabytes in a gigabyte. Yeah. Agree. Yeah. I had to think for a little bit. Nice. You want to take a make it and modify it. Do you know how to do it yourself, or are you going to do it in another place? What is 110 written in denary? All right. So this is 2, 4, 8, 16, 32, 64, 128, 256. Oh, no. Sorry, this is 1, 2, 4, 8, 16, 32, 64, 128. So 128 plus 32, that is 160. 160 plus 16, that's 176. 177. Hey! Yay, we got it. 177. Cool stuff. You always do it yourself, and then either, and if I don't know how, I look it up or break something and have to learn how to fix it. Goddamn. Wow. Is it still easy to do this with cars nowadays? I feel like a lot of cars, like a lot of cars are, like are protected by software, and it makes it harder and harder to like make it different. The more I learn, excuse me, the more I learn, the more I smell smoke. My brain is melting. Oh no, XR, don't melt. But I agree. The more we learn, the more like tired and I don't know. I get home. I did like every day. I get home this week. Every day, I'm like, ugh, ugh, between work and between you guys, and I think especially you guys, because there's a lot of work and like mental work. It's not work because it doesn't feel like work, but it's mental work to talk with you folks and then to think about the topic as well. Learning it, just the absurdity of things we learn is insane here. I just picked up like older stuff, 2006 and older. 2006 was the last good year of cars. Oh yeah, that's why we are hardware hackers, lol. I'm not sure what it refers to. Why? That's why we have hardware hackers. Well, 2007 had VPs in which were cool, but what? And then afterwards, like afterwards, the cars weren't as good. They featured seat belts. I'm kidding, but can you still find decent cars that are from 2006, 2007, or earlier? I would assume a lot of them are destroyed by now, no? Or like unusable. Take the GCSE Computer Science Quickfire Quiz. Okay, no, I'm not sure why I'm reading that. Which of the following is not an example of a stakeholder when considering the impact of technology? Ooh, this is a question for us. Which of the following is not examples of a stakeholder when considering the impact of technology? A business owner impacted by the actions of an organization. A vendor hoping to sell the software to an organization. Individuals impacted by the action of an organization. A manufacturer impacted by the actions of an organization. Okay, cool. That was kind of obvious. I don't know. They hack hardware like boards that monitor the newer car tech. Ah, game console hackers, iPod modifications hacker, hardware hackers. Yeah, they're fun. Seems like a lot of fun. I mean, dude, there's so many types of hackers out there, and I think you could make for quite a nice stream. Because hardware hacking might be very visual of an activity. It's not as easy as sharing your screen and doing it on screen, but it can be quite fun. Which of the following is a disadvantage of using a computer network? It is easy to share files between machines. Data can be shared and centrally. It costs more to build than just using a series of standalone machines. Yeah, does it? Networking two or more computers together allows resources, such as printers or internet connections, to be shared between them. It aids communication between the users and facilitates files being shared between them. Nice. Hmm. Kind of no shit, no? So, like, these questions are up and down. I don't know if it's just because some are easy and some are harder, or it's just some questions fit my skill set and others don't. Which of the following will not have an impact on the performance of a network? The number of transmission errors which are occurring on the network, Which of the following will not have an impact on the performance of a network? The number of transition errors which occurred on the network, reading a downloaded ebook on a reader whilst it is connected to the network, latency of the network, number of devices of the network at one time. What do you think? Which one do you think it is, folks? Find a network router, throw open WRT on it with. Ooh, we're low on battery. We need to plug our computer in. Open WRT on it with a WireGuard and create your own travel router that segments a public Wi-Fi into privatized Wi-Fi network on for own devices. Hardware hack. Yeah, it's ebook. Yeah, I agree. Wow, you're good at typing a comment and and reading the question at the same time. Yeah, it's the ebook. Find a network router, throw open WRT with WireGuard, and create your own travel router that segments a public Wi-Fi into a privatized Wi-Fi network. Hardware hack. No, I'm not gonna start hardware hacking. ADHD superpower, yeah. Are you a bit ADHD, Cyberpunk Reno? Man, you're really stuck with that name, huh? I'm really stuck with that name. In the sense that I was like, oh, Cyberpunk Reno, and maybe it's gonna be something else, but it seems like you're sticking to it. It's fun. Now, I still know you as XR, but there's still like a part of me that's like, oh yeah, it's XR. Say you're at a hotel, you don't want to connect your Wi-Fi networks. I'm diagnosed, so yeah, I can change it for 6 months also. I can't change it for 6 months also. I'm diagnosed, so yeah, and I can't change it for 6 months. Ah, you cannot change it. Ah, okay. Well, you answered 3 things at once. Nice. When designing a robust program, which of the following is not recognized technique for anticipating problems and protecting against them? Validation, selection, authentication, sanitization. Robust program, which of the following is not recognized a technique for anticipating problems and protecting against them? I have an idea. What do you think, folks? I want to say selection. I think it's validation. Oh no. Oh no. Cyberpunk Radio should listen to you. Selection. Sequence, selection, and iteration are key programming constructs when building programs, but are not techniques used when making a program robust. Okay. Recognized techniques include validation, which is checking that user input is correct, sanitization, which is preventing users' input from being harmful, authentication, which is checking the correct user logged in, and testing, which is checking that the code behaves as expected. So, when designing a robust program, which of the following is not recognized as a technique for anticipating problems and protecting against them? Whatever. I mean, whatever, but like, this is poorly explained, no? Sequence, selection, and iteration are key programming constructs when building programs, but are not technique used when making a program robust. Recognizing to include validation. So validation is in there. Sanitization, which is in there. Authentication and testing. What the fuck? Is not. Ay, ay, ay. Ay, ay, ay. Shame on us for not reading the prompt. Selection, authentication, sanitization. Ay, ay, ay. Oh, your score is 6 out of 10. Well done. No, I'm not retaking that. No, thank you. All right, we have a few more ones. We have a few more Quizzes online here. We just gotta find a way to actually do them. Open a new window. No, give me the quiz. Start quiz. Boom. Well, that's a pretty interface. What is the primary function of the CPU in a computer system? Did you read the quest log? What do you mean, did I read the quest log? Did I read the quest log? The quest log, the question, you mean? What is the primary function? Old joke, different group. I didn't read the question fully. Yeah, nice. Old joke, different group. Nice. What is the primary function of the CPU in a computer system? To store data permanently, to process instructions following the FDE cycle, to display graphics on the monitor, to connect the computer to a network. Was I right? I think so. Oh, we can't go back either, can we? No, we can't. Which component of a computer system is responsible for storing data long-term even when the power is off? Secondary storage. We learned this just now. Which of the following is not a characteristic of a von Neumann architecture? Ooh. Sequential execution of using FDE cycle. I'm not sure what FDE cycles mean. Sounds like an FDA process. We're gonna read about it, folks, just now. Fuck the quiz. DE cycle. There's always running out for someone. FD cycle. Something that like doesn't make sense to me how sometimes pen just stop working for no apparent reason. FDE cycle. Let's check out what it is. Cycle. Cycle. Le cycle FDE. Fetch, decode, execute. The basic repeating process that a computer's central processing unit, CPU, uses to run program instructions. Fetch, decode, execute. I stand corrected. Process instructions. Okay, you're giving us the answer to this one. Whatever you're to do. So you say parallel processing. So the question is, which of the following is not a characteristic of a von Neumann architecture? I kind of want to understand the FDE cycle thing. So I want to say parallel processing. So Cyberpunk Reno said parallel processing. Change his mind. There I go, not reading a question. Not a characteristic. Ay, ay, ay. Man. FDE cycle is the basic repeating process that a computer's central processing unit, CPU, uses to run program. Okay. Basic. Repeating. Program. Actually, process, not program. Process. For CPUs. For CPUs. Fetch, decode, execute. Decode. Execute. What does that mean? What does all this mean? It happens billions of times every single second to make your device work. 3 stages of the cycle. Fetch. The CPU gets the next instruction from the computer's memory, RAM, using an address stored in a special tracker called a program counter. Decode. The control unit looks at the instruction and figures out what action or calculation the computer needs to do next. All right, one more time. So fetch, the CPU gets stuff from the RAM. Let's write it. Fetch computer grabs. Oh man. Dude, don't you just hate pens that don't work? There should be consequences for people that make pens that don't work. What is this? JW Marriott. Shame on you. Computer. So fetch is all about computer getting instructions. Get instructions from the RAM. By the way, I'm gonna might dive into a rabbit hole here, but what is random access memory? Just as I said it, I'm not coming back from this rabbit hole. I will perish in this rabbit hole. Decode. The control unit looks at instruction and figures out what actions, calculation the computer needs to do next. Okay. So decode. Look at instructions and see what to do next and execute. Which is for doing the math. No, they're doing the math. Doing math. Move data. I wonder if this is the only thing a CPU does. Saving as a result. Saving result. So kind of the CPU is really not the CPU, but the RAM is the brain of it. Last set of pens I purchased cost me $20 for two. Zebra X701 to be exact. And you liked it? Man, we're transferring from a cyber and IT we're transferring from a AI hacking stream to more of a wider understanding computer stream. And today we've been shifting. In the past days, we've been shifting to a pen and pimping car stream. Ooh, usable at 250 Fahrenheit. 2 bonus refills. I'm not sure who wants to use it at 250 degrees Fahrenheit. Ooh, there's 2 cartridges in there. $17. It's used by people wearing military stuff, holding maps. Where are they at? Are they in Indiana? Is this Lake Michigan on the top left? I love them. I like high quality pens, lol. Yeah, it's pretty nice. Like some people will buy luxury. I don't get that, but buying a nice pen that writes well, it's pretty damn good. Someone holy oh, there's a...
Hey guys, Christina here.
Hey guys. This looks like an old video. Nice. Zebra pen. Nice. I don't get why people have reviews on their website if it's to show 3.8. Because a company should manipulate ratings to be better than that. Make it hard to give a bad review. or something like that. Like nothing on my website should be below 4.7. Retractable ballpoint pen. What do you guys think of the zero? Okay, so so it's a pen. It's not a pan, it's a pen that we like, that XR likes. Is FDE is the FDE cycle the only thing that is done by the CPU? Ooh, Jim the Dandy, cyber knowledge, more cyber poopage. Yeah, Jim. Jim changed. Jim, you went back to your old ways. Jim is from YouTube, folks. Could also be an imaginary person in my head. Love them. I like whole quality pens, Lord. Nice. No, FDE cycle is not the only thing that the CPU does, though it is the core loop that drives all processing. Beyond executing instructions, the CPU manages hardware communication, responds to external events, regulates its own physical states, and coordinates with other specialized chips. Core CPU activities. Handling interrupts. The CPU constantly pauses its regular FDE cycle to handle immediate requests from hardware, such as mouse click, keyboard press, or network packet arriving. Managing memory, context switching, power and thermal regulation. Man, it's crazy how much CPU does. It's really the core of. Is CPU the core of computing? Yeah, probably no. Yes, CPU is traditionally considered the core of computing because it acts as a central director and general purpose processor for the entire system. However, modern networking has shifted towards a heterogeneous architecture where the CPU shares the core title with other specialized processors. A general purpose flexibility. Okay. These are the features that make it shift to being central. General purpose flexibility. The CPU can handle any computational task from running an operating system to managing files infrastructure, whereas other chips are highly specialized. Okay. System orchestration acts as the manager of the system and sequential speed. So it goes really fast. These are what make it really good, the CPU. Now, what is taking over as well? This kind of captain title that has been working, that CPU has enjoyed for a long time. So there's GPUs, graphic processing units. We all know that. It's really useful in making AI models. Now, TPUs and NPUs, neural processing units. These are specialized accelerators. Now the core of on-device machine learning and AI smartphone features. I didn't know about that. Neural processing units. Do we want to learn about that? I think so. SoC systems on a chip. In modern devices like smartphones and Apple Silicon Macs, the CPU is just one component of a single chip that integrates graphic memory, AI hardware tightly together. Excuse me. Graphics, memory, and AI hardware together. Kind of down to learn about TPUs and NPUs. Well, we're learning from fucking Google bot. Are you interested in how AI chips and tensor processing units achieved by discarding the general purpose flexibility of a CPU in favor of massive grid architecture optimized for a single mathematical task, matrix multiplication? All right. So let's write this down. Man, we're learning many different things here. Splattering all over. Our knowledge is spilling into buckets and buckets of entertainment. I should write poetry. All right, TPUs and NPUs. Dude, fuck me. Why is this pen not working again? There's always when you do. Do 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 do. Hey, we didn't put music today. I think we should. That would help me get that music unstuck from my head. One second. Let me put that sweet, sweet music on. I'm gonna put that sweet, sweet AC on as well. That'd be pretty nice. Getting some fresh air, some I don't know, fresh but cold for sure. Let me put on that sweet, sweet music. All right, it's playing. Be right back, folks. I'm gonna put on the AC. Nice. Cool. So we are learning about TPUs and NPUs. TPU/NPU are accelerators that specialize in matrix. Is that it? No. Multiplication. Yeah, we got that right. Did you guys ever text multiplications? Did you ever take mathematical classes where you had these kind of grid multiplications? Matrix multiplications? I think I did, and it's kind of complicated. A little bit. Well, not that complicated. Not really. I think if you ask a mathematician, it's like, oh, pretty damn basic. But I remember I had to do it, and I had to do it, and yeah. Yeah, it was not that easy. Oof, I bugged out like crazy. TPUs and accelerators specialize in matrix multiplications, and they're used for thousands of operations cyclical where CPU processes one by one. Nice. So multiplications are specialized in matrix multiplications to run AI locally on smartphones. On smartphones, right? On smartphones. That's interesting, but I don't see why we would want to do it locally on smartphone. What are whoa. What are use cases for these devices on smartphones? 2 + 2 is equal to potato. What? I agree. Smartphones and NPU TPUs run artificial intelligence model locally on the device rather than sending data to a cloud server. As of 2026, this dedicated AI hardware enables real-time features across photography, audio, and user interface functions. Oh, so it's for photography. It's not just like basic prompting, it's more like it's little things that make it a little bit better. Audio interface functions and interface functions. Like if you want to improve, for instance, the quality of your mic to make the sound around you be more quiet, you need to probably have AI locally. You could always have it on the cloud and stuff, but I'm not sure if phone managers do this, because then it gets encrypted, right? The signal, I would assume. So yeah, I think it's better to put this on your phone, the AI kind of on your phone, so that the better quality is then transmitted and then encrypted, and then your receiver can hear it better, for instance. That's pretty cool. I didn't know about all this. Did you know that your phone could have AI capabilities just like that? Other than listening to you all the time. Oh. Alright, so TPUs and NPUs are that. Alright, so we kind of got deep into a rabbit hole. All of this to answer a question on a GCSE level, which I think is like grade school, something like that. Whatever. It's like young people kind of question. Which of the following is not a characteristic of Neumann von Neumann architecture? I have no idea. Bloop. Oh, apparently did we get that right, or what the fuck does that mean? Ah, no, it didn't say anything. It just we selected this one. What is the purpose of a system clock in a computer? To display the current time to the user, to synchronize the operations of all components, to store the system's date and time settings, to control the speed of the internet connection. Pretty sure it's to synchronize the operation of all components. Kind of want to learn what that is. What is a system clock? Well, actually, how do you use it? System clock. The system clock is a tiny crystal oscillator inside a computer or smartphone that acts as a metronome for the entire system, repeating regular electrical pulses to synchronize every component. Ooh. All right, let's write that down real quick. Real quick. It's crazy what the kind of thing we can do with crystals. I'm not talking illicit products here, just like watches and stuff. Like the vibration of a crystal make something work, like be synchronized. It's kind of crazy. System clock. It's a crystal oscillator that emits electrical pulses to keep everything in sync. It's kind of crazy. Just like, oh, put a crystal, it's going to vibrate at a regular pulse and create electricity, and everything is going to work around that. Insane. Every tick clock cycles allows the CPU to advance to the next step of an instruction. Where's this thing stored? People often the system clock with the time displayed on screen. The system clock that runs at billions of ticks per second just to pace hardware logic. In contrast, the real-time clock is a separate battery-powered chip that simply counts seconds, minutes, and hours to keep track of the human calendar time, even when the device is completely powered off. Ooh, it's battery powered. That's pretty cool. So even on if you have a tower and not necessarily a battery, that's good. Your clock is gonna work. I guess if you don't run it for a long time, then the battery's gonna run out. If you want to explore how the system clock impacts device performance, tell me. Do you want to know how overclocking forces the system? Yeah. Tell me about overclocking and about where this clock is stored on a computer. I don't say stored, but placed. Do you know about all these features, folks? I didn't know about all this. Overclocking is a practice of increasing a component's clock rate beyond factory specified speed to force performance operations per second. If you don't know, folks, overclocking is something that we used to do. I had a jailbroken iPod, and you can increase its speed by overclocking it, and the animation for the circle would go a lot faster instead of going. It's kind of crazy. That was the main thing I remember. Adjust user settings, the computer's BIOS UEFI to increase the multiplier. A base frequency of the CPU GPU. The voltage trade-off. Running faster requires more electrical power, so user must increase the voltage, which exponentially increases heat production. Oh. The risk. Without high-end cooling system, like liquid cooling, overclocking can cause permanent hardware damage, thermal throttling, or system instability like crashing. Silicon lottery. Due to microscopic manufacturing variations, some individual chips can handle much larger overclock than identical models from the same factory. Wow. Damn. That's pretty crazy. That just because it was made different, it works different. Where the clock is located. The quartz crystal, the physical core of the clock per pulse, is a tiny silver oval-shaped crystal oscillator soldered indirectly into the motherboard. The clock generator IC, located right next to the quartz crystal, is integrated circuit IC chip that takes the crystal's raw fixed vibration, usually 14.318 megahertz, and multiplies them into gigahertz signals needed by the CPU. Okay. I can't understand how regular do these pulses have to be. How bad would it be if one of them was, say, 10% shorter? The electrical pulses must be exceptionally precise, with variations restricted to less than 0.001. A few picoseconds. Holy shit. Cyber Noipai is here. Hey Cyber Noipai, when you design an any electrics, you never run at 100% unless you put a threshold. About 80%. The 20% extra threshold is pretty much the overclock. So it would be kind of breaking it if you had this much. Like if you had this much, you could actually damage the system. So you always put it 80% of its potential, right? Corrupted logic. Okay, so the metronome principle. If a virus arrives 10 minutes late, the next clock edge strikes before the electrical signal have finished moving through the circuitry. Oh, the CPU will read half change invalid state, turning a 1 into a 0, and vice versa. Yeah, if the CPU the CPU gets half changed, and man, yeah, it won't have time to finish the different things. Inset failure. This is a single corrupted bit, might be part of a virtual address or an operating system instruction, causing the entire computer to immediately halt to prevent further damage. Holy moly. Everything is just so crazy. You are at day 180, yeah, right? You and I have known each other for a little bit, Cyber Noipai. No, you came in like, what, day 120 or something? Cyber Noipai. Salut Natir. January 23rd. January 23rd, I must have been celebrating, yeah, something like 90 days before that. 90, what was it? So I started September 1st. So I did September, October, November, December. January. So yeah, a little bit before day 100, I think, yeah. Yeah, we're day 180. Ça va, ça va. We're doing some quizzes. And while we're doing quizzes, we're getting lost a little bit. So we're learning about the clock in a computer system. Did you know that every system, every computer had a clock which dictated all the hardware components? Kind of like a drummer in an orchestra, just keeps everyone in check. The other day I had a thought about how much music, like how much was the use of the drum in enjoying music versus in leading people. Does that make sense? In leading other instruments. Like I think the drum is also a leader for everything, whether it's the other instruments or the dancers and everything. It's just that. And I think when we compare the drummer to in music to an operating system thing, it's the system clock. You have me want to go back and learn this stuff again. Nice. Sever Norpai says, I'm pretty sure the same logic as having a mileage on a car. On the car. Why is everyone talking about cars lately? Man, there's Brooke, there's Cyber Noipai, there's Rouse. Man, y'all need to stop talking about cars. You do whatever you want. As long as it's not disrespectful or anything. Like, I don't mind you talking about cars. Everyone's talking about cars lately. Crazy. Alright, to synchronize all the operations, nice. Which of the following is not one of the main register inside the CPU? I have no idea what these do. PC program counter. GPU, I think. Maybe it is. But I have no idea. What is a function of the ALU, arithmetic logic unit in the CPU, to control the flow of data within the CPU, to perform arithmetic and logic operation, to store instructions temporarily, to manage input and output devices? What is a function of the ALU, arithmetic logic unit in the CPU, to control the flow of data within the CPU, to perform arithmetic and logic operations, to store instructions temporarily? I have no idea. When in doubt, is this a quiz about it all? This quiz is about CPU.html, quiz engine. It's about CPU. We have 10 questions, and I hope we're going to get the answer at the end. Which of the following action would most likely improve the performance of a CPU? Increasing the amount of RAM, increasing the clock speed, adding more storage space, installing faster graphic card. So yeah, increasing the clock speed, I think. What is the purpose of a cache memory in a computer system? To speed up the process by storing frequently used data. I think that's what it is all about. What does the term embedded system refer to? A computer system with a larger system designed to perform a specific task. So embedded system, I think it's about having it close to you, no? A system for general purpose computing, so I don't think that's that. A system that connects multiple components and multiple computers and network, no. A system for gaming and entertainment. I actually don't know what embedded system is. Is it a computer system with a larger system designed to perform a specific task? A system used for general task? A system that connects multiple computers and network? A system used for gaming and entertainment? So I don't think it's the last two. It might be either one of those. Local Dadman. Oh, right, Local Dadman. You came here before. What an epic name. This is only your second message. Hey, Local Dadman, welcome. We're doing a little quiz. A little pop quiz on the CPU, and honestly, we have no idea. I mean, come in. We have some idea. I think we'll see the quiz results right now. Which of the following is an example of an embedded system? A digital camera, a gaming console, a server, and a data center. I have no idea. Desktop computer. Finish quiz. Ooh, 7 out of 10. That's not too bad. A 7 is a very respectable grade in Spain. It is even more respectable in France. In the US, it kind of sucks though. In the US, you get a C with a 70. One more point off and then you get a D. And D's are bad. Digital camera. Alright, maybe we got that wrong then. Secondary storage. Okay. What is the following is not a characteristic of the von Neumann architecture? Do we want to learn about the von Neumann architecture? Maybe. I like architecture. The von Neumann architecture is a computer design model featuring a central processing unit, a shared memory for both data and program instructions, and inbound-outbound mechanisms. Input from device, output from device. Control unit, arithmetic logic registers. Memory unit. So one more time, the von Neumann architecture is a computer design model featuring a central processing unit, CPU, we know about that, a shared memory for both programs and program instructions. Is that RAM? Shared memory for both data and program instructions and input-output mechanisms. The CPU central processing unit houses the arithmetic logic unit, ALU for calculations, the control unit to direct operations, and faster temporary storage registers. How it works: to fetch, decode, execution cycles. Instructions are fetched from memory one at a time, decoded by the decoder unit and executed by the CPU. The bottleneck: because data instructions share the same bus path, the CPU cannot read an instruction and read-write data at the same time. The delay is known as the von Neumann bottleneck. Oh, so von Neumann is the architecture that is used nowadays in CPU. It kind of leads the FDE cycle, I think. Okay, let's not dive too deep into that. I think that's a little too deep for us. A little too deep for now. What is the purpose of the system clock in a computer? To synchronize operations of all components. Which of the following is not one of the main registers inside the CPU? The GPU is not part of it. What is the MAR? M-A-R. I kind of want to just learn that. Maybe accumulator too. Okay, maybe CPU counter too. Explain these Man, it's crazy that you can just get AI for free nowadays. Like, everywhere you get AI for free. It's insane. I wonder how long that's gonna last. Like, Google just giving out their information just like that without you having to look at an ad and everything. Like, something's gonna change eventually. It's so strange that all of this is free. Like, I can just type in my question and get an answer just like that. It's amazing it's free, but, you know, YouTube used to not have ads and stuff like this. I think we're facing one of these questions here. Some people give out paper clips for free. That's true, huh? I agree. Unbelievable. Unbelievable. Like, how do you make money when you give out paper clips for free, right? Rabbit paperclip? You just don't. All right, MAR is Memory Address Register. It's a dedicated ultra-fast temporary storage slot inside the CPU. Ooh, okay. It remembers where everything is put, right? It's like the quick access. My God, there's so many components to everything. I mean, I don't realize it. I don't think a lot of people realize it, but computing is so amazing. It's arguable whether it's free, though. Tell me more. Like, what do you think they get from using this? Explain these MAR PC. Like, they're building a profile on me, maybe? Kind of. I guess they can use this data to sell me better ads. I'm curious to hear your thoughts about this, actually. Elou souci. Elou souci. Elou souci. Souci. Yeah. I'm not sure how to pronounce it. Souci. The one S and the two S is hard. But yeah, tell us about your point of view. MAR. MAR. Memory Access Register. Memory Access Register is an ultra fast temporary storage slot located inside the CPU. Boom. For holding the physical addresses of components in the CPU. I wonder if ads selling your data, etc. Some way they always make money. Well, you don't have to pay for the product. Yeah, true. Yeah, they'll do ads and everything, but what I mean, like this right here is actually free. Like there's no ads or any, like maybe they'll make money on other products that they have, but this right here is free. Everyday analogy, it's like a clipboard holding the exact house of a shelf number where the warehouse member needs to go and pick up a box. This is really important. I wonder if all these different components of the CPU are done by the same manufacturer. Does Intel make the CPU and the MAR, or do they rely on someone else to make the MAR? Is it made in another factory that specializes in MAR manufacturing? It's like it's interesting. I feel like it's really interesting, the business side of it all. Like there's so many little components. It's like same question is because we're all talking about cars lately on the stream. If we have a car, like is it like there's many little manufacturer suppliers that will supply, I don't know, the steering wheel or different buttons, I think, no? Maybe and then there's some that assemble different things. Like it's all like we all make tiny little things that fit into tiny little things that make a bigger product, right? And maybe CPUs is like this too. All right, GPU, we kind of get the idea, no? But a program counter, this we don't know. Acts as a coordinator of fetch decode cycle. A job holds the memory address of the very next instruction waiting to be processed. Wow. Program counter. It is a specialized CPU register. Specialized CPU register that holds the address of the very next instruction. I wonder how it works with the MAR, right? Because it kind of does the same thing. No, it doesn't. So the I like how I just answered my own question. Like I asked the question, I answer it immediately. So the program counter will remember the next instructions. Will store the immediate next instructions. Maybe it acts as a buffer. Like here's what we need to do next. It kind of accelerates things. Because if the CPU needed to wait for another program, maybe that will take a while. But this thing handles the next instruction. Wow, CPI register that holds the address of the very next instruction. And the MAR knows where everything is stored. That's how you know you're learning, when you're describing the question and answering it. When describing the question answers it, that's true. Nice. Are you? Yeah. Local dadman, are you kind of learning stuff here? Or do you know everything? I wonder to what extent you all just already know this. Because I think you all come from more technical backgrounds than I am. Like, at least the chat, it feels like you folks are super knowledgeable when it comes to the highly technical things that I don't necessarily know about. And the accumulator is the primary temporary register located inside the CPU's arithmetic logic, ALU. Its job holds the immediate, midway, mathematical or logical result of whatever calculation the CPU is doing right now before saving it back to the main memory. It's like the M+ memory button on the current running total displayed on a pocket calculator screen while you're in the middle of a long math problem. Holy moly. Holy moly, what a great comparison from, what is this, Gemini? It's like a ultra fast Gemini model. I have my CISSP, but learn every day. Man, I'm studying for the CISSP. Do you have tips for me? Local dadman on how to study for the CISSP? I'm aiming to pass it by the end of the month, but I'm asking for my company to pay for it, but they're not giving me the answer for whether they're gonna pay for it. So I'm kind of like, well, I'm kind of ready, but if you're not gonna pay for it, I don't know. I might do it regardless, but I'll be a little bit annoyed if they don't pay for it. Temporary register to hold on to output of calculations. I think it's the simplest or description you can give it. Like any exam study, guides and practice exam helped me. Yeah. My idea is that I did some practice exams and I realized, and this helps me realize the things I know least. The things I know least. It helps me realize the thing I know least, and the exam, yeah, helps me realize the thing that I know least, and dude, why am I so slow? And my God, I can't get back on track. And yeah, focus on these. So I've been focusing on exam first, study, exam, pass. Nice. Yeah, so I did the exam, study, exam, and then pass. I agree. And then I figured out that networking I kind of wasn't very good at, which is something that I knew. So now I'm doing the networking course because I paid like $10 for a course. It's crazy how cheap knowledge is nowadays. Like, knowledge is really cheap nowadays. You can come on my stream and learn a thing or two, but there's dedicated also videos on YouTube to learn about different things. You can also pay $10, $10, and you can have amazing education, 20, 30 hours of courses on advanced computing. Access to knowledge is everywhere. Knowledge is everywhere. Everywhere. All right. I want to ask a supply chain question that I asked earlier. I would like to understand how the fabrication of these chips and its supports work. Does Intel, for instance, build out all the components themselves from raw materials? Raw materials is basically copper. I'm not sure, all the different metals, but I think not really. No. From raw materials, no. They must have. They must buy some like treated metals and stuff like this. You can't just go for that. Man, Twitch is being annoying. Do you get this on the chat, like incentives to always like fulfill an objective or something? Gift a sub and stuff. And even I can gift a sub. Crazy. Theme your gift. I keep getting these pop-ups to like give to the stream. Does Intel, for instance, build out the components themselves or from materials, or do they rely on some other manufacturers for their accumulators and pretty sure you all don't have an idea about this one though. And MR about this question. MAR. Intel fabricates its processors, including several structures like the accumulator and MAR, directly into a single piece of silicon. But they do not build every physical component from scratch or source all raw materials themselves. The monolithic microchip nature. Yeah?
I just want to tell. No worries.
Want to tell. Cool. The accumulator, MAR, CPU comes as separate parts. Idziesz do siłowni? Dobra. The accumulator, MAR, PC, CPU cores are not separate parts brought together from other companies and glued together. They are microscopic patterns etched into the exact same piece of silicon, the die. Ooh, okay. Whoa. Let's read this one more time. The accumulator, MAR, PC, and CPU cores are not separate parts brought from other companies and glued together. There are microscopic patterns etched onto the exact piece of silicon, the die. Intel designs these circuits and manufactures them simultaneously using advanced photolithography. There's purified silicon ingots, wafers from specialized chemical companies like Shin Etsu in Japan or Siltronic from Germany, rather than mining or refining silicon themselves. Yeah. Manufacturing machinery. Intel cannot build chips without photolithography machines. They build these on multi-million dollar machines exclusively from ASML, Netherlands. We heard about this before, no? Seeing how the world supply chains relies on one company, and it's this one, ASML from the Netherlands. The other company in the world that makes extreme ultraviolet lithography systems. The only company in the world that makes extreme ultraviolet lithography system. It's pretty insane that one company makes all machinery for extreme ultraviolet lithography systems. Damn. All right, so let's check this out. Purified this. I want to check a photo of it. I want to check a photo of an AI of an Intel chip. What can I search on Google to get an image of a CPU with all its components highlighted? I kind of want to see what all this looks like. Is it going to pull out photos for me? No. Quotation marks didn't help. Ooh, okay, nice. Integrated heat spreader. Substrate, contact pads, edge contacts, CPU cores, cache memory. Ooh. Shekhar G asks, Doctor, what seems to be the issue today? I don't know. What do you think why do you think there's an issue? The day's beautiful. It's Thursday evening / Friday morning. Pretty damn good time to be alive, no? Shekhar G. A little bit hot, and it's not gonna get colder, but what are we doing? I mean, what seems to be the issue today? Today we're studying we're doing some quizzes about different things. And the second quiz that we did, right now we're on our second quiz, and we did a quiz on CPU. And we're learning how little we know about CPU. This is what we're up to. And so we just learned about the little different components that make up a CPU, like the MAR, like the program counter, and the accumulator. And now we're looking at what it looks like on a CPU chip. CPU chip here. Computer path shala.ai. So a little bit like looking into what all this does. There's retention notches, integrated heat spreader, substrate, contract pads, pins. Oh, this is quite recent. It's like 2 weeks ago. The CPU, central processing unit, is the main processor of the computer. It performs calculations and executes instructions from both software and hardware. Cache memory, CPU core. Okay. We still won't really see the MAR and everything like that. But yeah, you need these very high precision machines to make these kinds of things. So tiny. You see. Nice. Oh, wow. This Instagram account just posts their notes. Important correction cautions. Use correct program structure. Main should return an int. Well, all they do is that. Computer pashala. Oh wow, they're doing kind of a lot of things. Excel here, count and count a formulation. Quite right of an Instagram account. Cool. Cool. So we did this quiz. Let's figure out what else we did incorrectly. What is the function of the ALU? Arithmetic logic unit in the CPU. So to store instructions temporarily, that would be the program counter. To perform arithmetic and logical operation. Do you want to learn real quick what the ALU is? What does the ALU do? Real quick. We're just going to take a quick note of what the ALU does. This way you can understand coding. This way we can understand computers a little bit better, CPUs a little bit better, and therefore when we understand computers better, we can hack them better. Genius. Evil plan. Just kidding, we're not evil, but kind of. Kind of. Everyone's a little evil, no? Everyone wants a little bit of that sweet, sweet power and control. ALU. ALU means it performs basic and complex mathematical, including addition, subtraction, multiplication, and division on binary numbers. Is that all it does? The two core functions, and it does logic operations. It handles Boolean logic comparison, checking if conditions and or not, and determining values are equal to or greater than, less than. Okay, wow. There's a digital circuit inside the CPU that performs all the actual mathematical calculations and logical decision making for the computer. Wow. Performs. It's like a digital circuit. Let's put digital circuits. Digital circuits. Folks, at the end of the stream, what we'll do is do a little recap of everything that we've learned in the past 3 days about computers. We've been doing a little bit of a deep dive into computers, and I think it's relevant to talk about it, and so that we can share the knowledge all together, learn, and be better hackers thanks to that. It is getting hot, folks. It is getting hot. I will take off the lab coat, if you don't mind. Yeah, it's too hot. Boom. So the ALU is the digital circuits. So pretty helpful. Digital circuits. What the? Okay. What is a digital circuit? All right, I'm gonna ask this real quick. What is a digital? Quiescent. A digital circuit is an electronic circuit that processes information using discrete electrical voltage level representing binary values as 1 and off. Okay, that's it. Okay, digital circuit is an electronic circuit that processes information using discrete electrical voltage. That's all we need to know. Got it. That performs all actual mathematical computations. Digital circuits that do the math. That's all I want to know. You were supposed to be a cyber doctor. My immersion is broken. That's true. Yeah, I don't see how you'd be a doctor without that lab coat. It's like, no. This cannot happen. I agree. Hope you'll find the chance to forgive me. Hello, Souci. First time you're here. First time you're chatting, at least. And I'm taking off the lab coat. I think it's a lack of respect on my part, and I should write you an apology letter. Increasing clock speed improves the CPU speed. All right, speed up processing by frequently used data. Okay, cool, we got that right. What does the term embedded system refer to? Okay, cool. You know what? Folks, I work in medical devices where we always said embedded system a lot. I thought it was always something in part of something. Embedded for me means inside of something. But maybe I'm wrong. Define embedded. Embedded. The word embedded means firmly fixed, set, or integrated deep within a surrounding whole. There we go. It means it's like it's part of something else. but not apparently according to this site. A computer system within a larger system designed to perform a specific task. Okay, that's what it is. So we were right. We just couldn't read the question, right? XR, ADHD a bit here. I think I share that a little bit, but just the AD part. Embedding system. So it is a computer within a larger system designed to do a specific task. Boom! Are you French? Yeah, you hear it? I'm French. You got me. So yeah, digital camera is not itself, it's an embedded system. It makes sense, no? Because it relies on other components. It does a special function within the whole a wider computing system. And who was it that was right? Someone told me the answer. A digital camera. It was Local Dadman. What a cool name, Local Dadman. I like it. What gave it away, my Frenchness? Is it the accent? You can hear it every once in a while. It just like sticks out. No. Try to keep it in me, but can't fake it forever. All right. Cool, folks. Last quiz, I think. Memory and storage quiz. GCSE level. Buy a coffee. Shop online. You look pretty cool. All right. Primary memory. All right, let's not spoil ourselves. Let's do the freaking quiz. What is the main purpose of RAM in a computer system? To store data permanently? No. To temporarily hold data instructions while the computer is running. To manage the operating system. To connect external devices. No. What is the following example of a secondary storage? So secondary storage, we learned it before. Secondary storage refers to anything that keeps data if the computer is turned off. Well, is that RAM? Is that cache? Is that hard disk drive? And that is, folks, that is hard drive. Cache and registers are all temporary. You turn them off, they go off forever. You turn off the electricity, it is off forever. What is the primary advantage of using solid-state drives over hard disk drives? SSDs have higher storage capacity? No, that's actually the opposite. HDDs usually have higher storage capacity. SSDs are cheaper per gigabyte? No, that's not true. Have faster data access times. That is the difference. That is the difference. Which type of memory is non-volatile and retains data even when the power is turned off? Oof. ROM? Read-only memory? I think so. Don't hear it that much. You said something out, GF, earlier, but I wasn't 100% sure. Ah. She's my wife, and I was speaking Polish to her. She's Polish, and I speak a little bit of Polish. So I was like, are you going to the gym? That's it, folks. Nothing too out of this world. What is the purpose of virtual memory in a computer system? I actually don't know what virtual memory is. Virtual memory? What is the difference between a virtual memory and a virtual memory address? So it's totally random then. You got me. Sometimes you get caught with random things. What is the purpose of virtual memory in a computer system? I actually don't know that one, though. To permanently store data? No, probably not. To allow the computer to use secondary storage and as the extension of RAM? I don't think so. To increase the speed of the CPU? maybe, to manage the operating system files. I think it's that last one. I think it's that last one. But yeah, Hello Susi, I think you might have been picking up sometimes there's a little bit of accent that comes out in some words. It's like my brain has been wired for French for the first 11 years of my life, and then I had to speak another language. So there's still bugs in some nodes of the neural networks in my brain that want to pronounce certain syllables a certain way that haven't been, let's say, fully fixed yet. And man, when I speak Spanish, I have a strong French accent. It's just how it is. It's just how it is. You can't get rid of that that accent. It's just part of you. What is the purpose of virtual memory in a computer system? I think it is to match this. I want to ask real quick, what is a virtual system? What is a virtual storage? Virtual storage, most commonly referred to as virtual memory, is a memory management technique used by operating systems to emulate more high-speed random access memory than the computer physically possesses. It maps virtual addresses by a program into physical address into computer memory or secondary storage. Nice! Someone followed. Who is this? Renberg31. Thank you very much for following us. Appreciate it. It maps virtual addresses used by a program into physical addresses in computer memory or have secondary storage, making a portion of the hard drive or solid state drive behave like temporary RAM. It maps virtual addresses used by a program into physical addresses in the computer memory or secondary storage, making a proportion of the hard drive solid state drive behave like temporary RAM. So that's what it is. Okay, so it is, we're not going to change our answer because that would be cheating. But yeah, it's actually this one. Virtual memory is basically allows you to extend your RAM. Yay! Vohayo. Nice. That's a cool sticker. I like it. That's a cool emote. Which of the following is not a characteristic of a ROM, read-only memory? I don't know what actually ROM is. I'm going to cheat and completely read what ROM is. What is ROM? ROM. ROM stands for read-only memory, which is a type of non-volatile storage chip inside computers and electronics that permanently holds essential instructions required to start and operate the device. Holds essential instructions required to start and operate the device. Ooh, okay. So this is pretty damn important. ROM. Storage chip inside computers and electronics that permanently holds read-only memory. Holds essential instructions to start and operate. Did you all know this already? A device. I didn't know this before. I kind of did, I think. I knew it existed. I think I might have been able to say it stands for read-only memory. But the fact that it's used to start, I don't think I can. I could have told. Essential instructions to start or operate a device. So yeah, without it, you can't start a device. Interesting. What were we asking about before? And of course, even if there's no voltage, it remembers stuff. Of course, if it was no voltage, then powering on wouldn't work. Like, I don't know, it'd be silly. So, but this thing kind of has to update. No, that's the question that I have. It has to update. Why is it called read only? Doesn't it also get updates? Like, it's supposed to get updates, right? For patching and stuff like this. Gets its name from a historical design rather than its behavior. Under everyday conditions, the computer can only read data from the chip and is physically blocked from writing it. Why their name persists despite updates. Hardware wall. In normal operation, the CPU's write circuits to ROM chips are completely disabled or lack the specialized electrical pathways required to modify the transistors. Specialized update process. Updating a modern EEPROM, that's a long one, or flash ROM, called flashing, requires a deliberate high-risk software routine that bypasses normal system limits using specific voltage spikes or blocks of data to slowly erase and rewrite the chip. Ooh, holy moly. Write endurance limits. Unlike RAM, which can be written to trillions of times per second without wearing out, ROM chips can only survive a limited number of write cycles, often between 10,000 and 100,000, before the physical hard drive degrades. Legacy terminology. The term ROM remains the industry standard because it distinguishes this permanent boot-level firmware storage from its volatile RAM, random access memory, which is designed for constant high-speed reading and writing. Incredible. Think of ROM like a fixed storage that can't be written to again. Like when you hold down a reset button, wink wink. Oh, what is that from? Did I hold a reset button? Wink wink, long it, and reset factory defaults. It is the original shipped software design. I was browsing through the our internal jokes rabbit paperclip. I couldn't find this one. Hold the reset button. Did I do this at one point? Like ROM, like a fixed storage that can't be written again. Things like pressing down a button. Okay, I see what you mean. But aren't there vulnerabilities in these kinds of things in ROMs? There must be, no? What do you do if a ROM has a vulnerability? And I wouldn't. When a vulnerability is discovered in ROM, the method for fixing it depends entirely on whether the chip's hardware can be electronically rewritten. Because ROM holds critical low-level boot code, fixing these security flaws required specific hardware or firmware intervention. Apply firmware update. If the device uses your modern EEPROM or flash ROM, as most computers, smartphones, and routers do, the manufacturer will release the firmware updates such as BIOS UEFI patch to overwrite the vulnerable code. The process: user downloads a secure update package that temporarily bypasses normal read-only protection to flash the new patch code into the chip. Okay, so you can't update it. It's like loading the originally shipped software. Yeah, it's like a little bit of a factory reset and everything. Interesting. It's crazy. Man, we've learned so many things about computers in the past 3 days. All right, let's finish up the quiz. Let's finish up that quiz. What is the following is not a characteristic of ROM? Non-volatile, that's true. Can be written to it by the user. Oh. Used to store in firmware. Data is retained when the power is off. Just quick question here. What the fudge is firmware? How are you folks seeing? I'm not sure if you're seeing very well. Now you're seeing better. Firmware is a permanent type of software embedded directly into a piece of hardware that gives the device its basic foundational instructions on how to operate. So firmware, it feels so basic, folks. Firmware is something we talk about all the time. But for some reason, maybe I did kind of know what firmware was. The factory program chip inside the engine control unit. Okay, so firmware is software embedded in hardware. That's all it is, right? It's like the pineapple and the pizza. It's a little bit of sweetness on a salty dish. What is the role of cache memory in a computer system? To store data permanently, to speed up data access by storing frequently used data on the CPU. Didn't we do this? Which of the following is a type of example of optical storage? USB hard drive, DVD hard disk drive, solid state drive. So optical requires light. I'm not sure, huh? As an example, DVD, I think. What is the main difference between RAM and ROM? RAM is not volatile, while ROM is volatile. No, it's the other way around. RAM is used for temporary storage, while ROM is used for permanent storage. Which of the following is a benefit of using cloud storage? It is always faster than local storage. It allows data to be accessed from anywhere with an internet connection. It is immune to hacking. It does not require any security measures. Okay, all of them were pretty easy. We just messed up one, which we knew about already. What is the purpose of virtual memory computer? It's actually to allow the computer to use secondary storage as an extension of RAM. Boom! Interesting, isn't it, folks? I'm surprised none of you started a riot from me saying the pineapple on pizza thing. If I watched a streamer saying this, I would have came over to their house and explained them the crimes that they're committing. All right, folks. It's Friday. Friday, Sunday, happy day. Let's do a little recap of what we learned throughout this week. All right. Feet on the table, microphone against us, and we're going to read a little bit. So, computers. A computer controls billions of tiny electronic switches which go on and off. Simple, right? A bit can be either 1 or 0. Microsoft 64 bits means that the computer features a 64. The computer's CPU features 64 bits. And when old Microsoft 32 bits could only leverage 4.3 gigabytes of RAM because that's all the addresses that it could reach. So back then, Microsoft 32 only had 32 bits, which can store 4.3 gigabytes of data because that's all the different possibilities that there were. And so even if there was more memory, the system couldn't use it because it didn't have this need, it didn't have this capability of processing more numbers. So this is why we shift to 64 now, Microsoft 64. And we have a long way, we have a lifetime, most likely, of us working on Microsoft 64 because Microsoft 128 is a long way away. Is in a galaxy far, far away. All right, and we did the difference between physical address and virtual address. So physical address is an actual position on a RAM or a CPU. It's like an actual position. It's like it is there and it will always be there. It is the bit number 34. Or it is, a certain number of bit, or bit 3 million something, or 3 billion something. So it is a position. And a virtual address is actually something that is made up by the CPU to organize things in the computer. It's basically saying this address will be the address dedicated to Google Chrome, and this will be their third bit or their 1 billionth bit. I'm not sure Chrome uses that much space, but it could be their billionth bit. Then we talked about rings, folks. Rings is a pretty cool concept in permissions, where ring 0 is the absolute control of the computer. This is where the computer's admins decide to do things. Like you can do, what can you do? You can access every byte of RAM, you can configure the CPU, you can talk to hardware, you can create processes, you can really do anything. This is a place you can do anything. And ring 3 is the other most common one, where it's designed for applications. Like Google Chrome right now is running on an application. So it has its own dedicated part, and it cannot do all these things that we said. It cannot configure the CPU. It cannot just shut down the computer. It cannot do different things, because otherwise, if we didn't have these rings in place, everyone can just do everything. Oh, Chrome just wants to download this file and install it on... wants to do these updates on firmware. Google Chrome wants to do... No, we can't have that. It has to go through the operating system, which safeguards everything else behind it. Cool. Another thing we learned is that LLMs are deterministic. No matter what input you give them, the output will be deterministic. They can say, all right, the capital of France is, and then it will lead it with a probability of different things. Is London, is Tokyo, is Paris, and we'll give you the probabilities for each of them. And every time, from what I understood, yeah, LLMs are actually deterministic, so they will spit out the right probability each time. But the thing is, in order to make LLMs a little bit more interesting, in order to make them a little bit more creative, we're gonna change what's called a temperature, which is the creativity. Sometimes it will pick out some circumstances, it will pick up on some words that are not necessarily true. Does that make sense? It will pick out on some words that are not necessarily true. So it won't pick up on the most probable word every time, and that will generate some kind of entropy that will make the prompt a little bit more interesting. And that's varied through the temperature control. So temperature 0 means that there's no variation. And then we talked about pointers. Pointers are a variable who has a value is a memory address. Then there's different GPUs. There's GPUs that are directly integrated into the GPU itself, and there's dedicated GPU. Yeah, there's GPUs that use the system RAM, and there's dedicated GPUs that have their RAM collected as have their own RAM. So a GPU can have their own RAM, or they can have or they can use the system RAM. Now, the good thing about having their own GPU RAM is that it's usually right next to their GPU, and that matters a bit, because we did the calculations, and the transport time, even though it's pretty close to the speed of light, it's half the speed of light, it still takes way too long for waiting for it to come and to come back. If the thing is far away by, let's say, 10 centimeters, it takes forever. It takes a long time. It doesn't, but for computers, it slows it down by a lot. So having it close to the RAM, having the GPU close to its memory saves you a lot of time and optimizes capabilities by a lot. Now today, here's what we learned today. Secondary storage is storage that survives without electricity. FDE cycle. This is the cycle that every CPU goes through. It is basic repeating process for CPUs, which means fetch. FDE means fetch, decode, execute. Fetch is the computer gets instructions from the RAM. Decode is you look at the instructions and you see what to do next. And the last part is you execute. You do the math, you move the data, and you save the result. Are you actually a PhD MD? Or is it like a gimmick? It's a gimmick. It's not QWERTY. It's a gimmick. It's just for fun. We were a lab coat as well. I'm not sure if we've seen each other. It's not QWERTY. I don't think so. I think you're... Oh, no, you've come here before. No, that's actually your first message. No, it's just for fun. For being entertaining, having fun. Not to take away from the bit. No, all good. It's not QWERTY. I understand. You're curious about that. Most people ask questions. The lab coat, it all started with the lab coat a while ago. It was just for fun. Come on, I'm on stream. Don't put your feet. I don't usually take I was having a really good time just putting my feet up. Come on, have some decency. Yeah, it all started with a while ago when I was creating videos and was always wearing the same jeans jacket. I'm like, wow, I like wearing jackets. How could I take this further? And I like creating characters in my videos. I used to make videos on LinkedIn and stuff like this. And I created different characters, like the CFO in the company that held it's like kind of an uptight guy. And then I thought, who could I be? I also want to be a character. And I created this, I'm like, oh, Cyber Doctor sounds really good. Cyber Doctor sounds really cool. And there's not really anyone that was using this name, at least popularly. I'm like, okay, I want to be the Cyber Doctor. Sounds good. And I bought this lab coat, and but I made a really nice patch from someone in Pakistan. It was really cool. And yeah, now the story. But I don't wear this because it's a little hot. It's a little bit hot. I was wearing it earlier in the stream. Are you just for the last 6 months now studying IT, or do you have prior experience? I'll tell you about it. Let me just finish this and I'll tell you about it. It's not QWERTY. We also learned how TPUs and NPUs are accelerators that specialize in matrix multiplication. So it's really useful. Matrix multiplication is really useful for AI, because that's how you calculate vectors and you come out with outputs. And it's not just to run LLMs, but it's also to power AI features like the camera, like the microphone and stuff like this to optimize how it works. We also learned how system clock is basically a crystal oscillating that emits electrical pulses to keep everything in sync. So it keeps the hardware in sync by saying, okay, this is clock 1, clock 2. It's basically what is it called? The orchestra. Who's the leader in an orchestra? What do you call them, people? What do you call these people, these folks? The leader in the opera. Not the opera, the orchestra. They are the maestro? Is that how you call them? Maestro? That might be in Italian. Yeah, basically they set the rhythm for everything in the hardware. Conductor. They're called conductor. Same as the train. Alright, and then we have MAR. MAR, we learned about MAR. MAR is Memory Access Register, which is an ultra-fast temporary storage, which is located inside the CPU for holding physical addresses of components. It's basically the library of, yo, here's where we have all the things that we need. And then it will update, because sometimes the things will move around. And this MAR is in track of keeping everything in check. Then we have program counter, specialized CPU register that holds the addresses of the very next instruction. So just like a little bit of buffer. We're almost there, folks. We have accumulator, which is a temporary register to hold on to output of calculations. Yep. It's like a little saver for calculations. ALU is the digital circuits that do the math. Okay. Embedding systems are computers within a larger system designed to do specific tasks. Read-only memory. This was fun because something that you read a lot, but I don't think I ever had the full grasp on it. Is it holds essential instructions to start and operate a device. And lastly, we have software embedded in the hardware, which is firmware. Woof! That was what we learned this week. And it's not QWERTY. Asking some nice questions. It's not QWERTY is asking what is our experience? Our experience in this is our experience in IT. Okay, yeah, okay. Friday, and we're a little bit tired. So our experience is that I work in IT for now almost 5 years. Well, IT. So I started at CrowdStrike as a salesperson. And there I got fascinated by the world of cyber. So I learned about cybersecurity. And then I've evolved. Now I am in cyber insurance, where I look at companies, do assessments of their risk posture, and decide whether they fit our risk appetite profile, and decide on conditions, do some negotiation. And I realized like that I want to know a little bit more about I want to so I've been you're coming on the 180th day where we're focusing on learning stuff. Oof, I'm a little slow. Where we're focusing on we're focusing on getting better at IT. We're focusing on like for the past few days we've been focusing more on IT pieces, because I realized that we hit a ceiling a little bit with our knowledge of it. Where can I link some learning resources? Oh yeah, please do. Sounds really good. Thank you, Cordy. What's your background? It's not Cordy. Are you also in IT and stuff like this? If you have resources, I'm assuming you have a little bit of knowledge on it. You just sent an I. That's mysterious. Mysterious. Twitch. Let's see if there's some interesting folks to raid. How many of us are there? There's 8 of us. Okay, that's something. Let's see, who can we raid here? Trying to get more into publishing content. Oh, really cool. I'm a founder and software engineer. I work in intelligence software. What kind of intelligence? Cyber intelligence? I like cyber intelligence. My God, I'm getting distracted by someone playing an FPS right now. It's crazy the mechanics that these people have. It's insane how they can just like she's just sitting and chilling, and yet she's doing some highly complex stuff at the same time. It's pretty damn incredible. So you're publishing content on social intelligence, mainly strategic manipulation. Oh my God. You work on intelligence software. Signals intelligence. Trying to get more in publishing content, signal intelligence mainly. I'm gonna ask AI about this. I'm not sure what it is. What is? I have an open source browser fingerprinting library that's about as accurate as Fingerprint.js Pro. It has some real strategic benefits over it. What's a browser fingerprinting library? Wow. A browser fingerprinting library. If a browser fingerprint library is a code package that collects device and software settings to create a unique ID. I'm going to share with you. Let me put over there myself in the corner. A browser fingerprint library is a code package that collects device and software settings to create a unique ID. Ooh, I see. Fingerprinting library that's about as accurate as Fingerprint.js Pro and has some real strategic benefits over it. So basically it allows you to track your users a bit, no? Say like if you have an e-commerce and you wanna track who's been on your platform, are they coming back and stuff. It's you I'm trying to avoid. Yeah, I guess so, huh? Gateway corporate papers, FP device drivers, PDF. Here's my white paper. Feed that through the AI. It's 35 pages, FP driver. So, if you made a paper, so you're an entrepreneur, right? Trying to create some content. Confidence calculator. I'm looking at the paper here, folks. You can't see it. I opened it here in a... Wow, man. Pretty damn impressive. That's a lot of math. Where W is the effective path weight and sim between 0, 1 is the path comparator output. Holy moly. Some technical stuff. You know, I don't necessarily miss math too much. I was thinking about it. It's okay. I like understanding stuff, but I don't need to get deep into it. Man, pretty cool that you're doing all this. Good luck in that project. I think it's really cool. Feed that through the AI. Folks, we've learned a lot today. We've learned a lot today. It's been really fun. I'm a little slow. So yeah. Folks, hope you have a nice time. I was it for today, and I will see you on Monday. Right? Monday? Yeah, nothing's happening. I'll see you Monday, folks. Be sure to follow if you haven't yet. It's really fun. We're here every workday. In Europe time. So today's Friday for me. Ciao, Lucy. Nice meeting you. Thank you for chatting for the first time. Same for you. It's not Cordy. Nice seeing you for the first time. We've had a bunch of people in the chat, so it was really cool. Yeah, folks, please take care. Enjoy your day, and I'll see you very soon. Ciao all.